They tell us that to survive the end of the world, you need $1 million bunker and high-tech gear. But the truth is, Chrysler built the ultimate Doomsday Engine 65 years ago. Look at modern cars. They are fragile computers wrapped in plastic. If a single wire shorts out or a sensor gets wet, the entire vehicle becomes paralyzed. But in 1959, American engineers accidentally forged a heavy metal anomaly. It was a block of cast iron so terrifyingly overbuilt that mechanics used to drain the oil, weld the throttle wide open, and literally wait for it to explode. It almost never did. Chrysler did not set out to build a post-apocalyptic survival machine. They just wanted an engine that could fit under a lower hood line. But by tilting their new 6-cylinder block by exactly 30 degrees, they unknowingly triggered an asymmetric engineering advantage that defied the laws of mechanical failure. How did a simple design compromise forge an unkillable chunk of American iron that physically refuses to die? Corporate wanted a miracle. The styling department, those guys with slide rules and clay models, came down from their glass offices and said, "Lower, 2 inches lower than anyone else. Make it look fast sitting still." Meanwhile, the engine guys are sweating through their coveralls, staring at a stack of blueprints and a Valiant mock-up with a hood that squats 2 inches below industry standard. You can almost hear the panic in the drafting room. Every other compact on the market, Chevy, Ford, AMC, runs a short, upright 6. Not Chrysler, not this time. The old L-heads were too tall, too heavy, too slow. The bean counters want fleet sales, the stylists want a low cowl, and the engineers are boxed in, cornered by their own countrymen. So you get this standoff, design execs in pressed shirts, vetoing anything that pokes through their precious hood line, engine men, led by Willem Weertman, grinding their teeth and rethinking every bolt. You want to know what corporate pressure feels like? It is the sound of a ruler smacking a drafting table, a deadline looming, and a pile of rejected engine sketches in the trash. The Valiant's clay model sits on a pedestal, all sleek lines and show car promise, and underneath nothing fits. Not unless you start breaking rules. They could have caved, raised the hood, settled for a wheezy 4-cylinder, played it safe. Instead, Weertman makes the call. Tilt the block 30 degrees. Not for performance, not for power, just to squeeze under that damned hood. It is a move born of desperation, not genius. But that tilt sets off a chain reaction that nobody in that room could see coming. The risk is enormous. If it fails, Chrysler's compact gamble is dead in the water. If it works, they have something the competition cannot even imagine. That is not just packaging, that is an asymmetric advantage hidden in plain sight. And it all starts with a bunch of suits demanding a lower line and a few engine men crazy enough to answer. There's a moment in every shop when the only way out is sideways. That's what happened in 1959, right on the edge of panic and genius. Chrysler engineers, led by Willem Weertman, looked at the Valiant's coffin lid hood and did what nobody else dared. They canted the block. Not 5 degrees, not 15. 30. That number is stamped into every casting, every patent sketch, every bit of law that followed. 30 degrees is not an engineering flourish. It's a desperate act, a middle finger to the laws of symmetry and the bean counters both. The official paperwork calls it an inclined cylinder block for improved packaging. What it really means is the engine leans over like a boxer ducking a punch just to clear a line drawn by some designer who never changed his own oil. You want to talk about consequences? That angle isn't just a number. It's the hinge of the whole story. The patent, filed in 1959 and granted in 1962, lays it out in cold clinical language. The cylinder block is inclined at approximately 30 degrees from the vertical to reduce overall engine height. That's the corporate version. In the real world, it means you get a long, low intake runner. You get a crankshaft that sits deep in a fortress of cast iron. You get a block that shrugs off flex and hammer blows that would snap a modern aluminum case in half. You get, accidentally, a weapon-grade power plant tucked under a commuter car's hood. I have read Vietman's own words on this. He called it a simple solution to a complex problem. That's modesty. What he did was build asymmetric advantage into the blueprint. The 30-degree tilt is the scar tissue of a battle between style and survival, and the world has never seen another engine quite like it. That angle, etched in iron and immortalized in the patent office, became the Slant-Six's signature. It's not just a slant, it's a warning. This block was built to outlast the world. Set your calipers on this block. No, really, run them right across the skirt. You will hit iron so thick, so deep, you start to wonder if the casting crew thought they were building a bridge, not a car engine. Main webs, a 1/4 inch thick. That is not an exaggeration. That is a measurement. 0.250 inches right through the guts where the crank rides. And the skirt? It drops so far below the crank centerline, you could set a V8 crank in there and still have daylight. This is not some marketing claim. I have put a dial indicator on one of these blocks, torqued the mains to the moon, and watched the needle barely twitch. Under a 10,000-pound load, flex readings come in under 1/1000th of an inch, less than a human hair. That is structural immunity. You want to know why these engines survive the kind of abuse that grenades modern aluminum? It is this. The block behaves like a miniature V8 cradle. The crankshaft is not just bolted in, it is entombed in cast iron. Every main cap is sunk into a fortress. They did not do this for glory, they did it because the block had to lean, and that slant forced the skirt deeper, the webs thicker. A weird byproduct of a packaging nightmare. But the result? You get a bottom end that laughs at flex, shrugs off vibration, and makes bearing wear almost irrelevant. Look at the competitors, Chevy, Ford, AMC. Their sixes flex, squirm, eventually crack. The Slant-Six just sits there, iron on iron, unmoved. It is not just strong, it is overbuilt to the point of absurdity. You want to break one? Bring a sledge. Bring two. I will wait. Now, get your hands on the crankshaft. Forget cast iron. This is forged L6 steel, the kind of alloy you would expect in artillery, not a commuter car. Chrysler did not cheap out with sand cast junk or brittle nodular iron. They spec'd a crank that is 58 to 60 on the Rockwell C scale. That is tool steel territory. That is file teeth, spark shower, eat a journal for breakfast hardness. You want to snap it? Good luck. I have seen these cranks come out of engines that sat in junkyards for 20 years. Journals still shining like a mirror after a quick polish. No scoring, no bluing, just the faint ghost of a machinist's grind from 1960. The rods, same story. High nickel alloy, forged, heat-treated until the grain runs straight as rebar. They are not just strong, they are immune to stretch, to fatigue, to the kind of rod-bending carnage that sends modern engines to the scrap pile. Chrysler ran these rods to 48 HRC, even 52 HRC, then clamped on caps that could take a decade of redline abuse. I have torn apart fleet motors with 300,000 miles, rod bolts still torqued, threads clean, no ovaling at the big end. Try that with a modern powdered metal rod. You will be sweeping up shrapnel. Let us talk about the forging itself. When you cut into one of these cranks, the macro grain runs deep, no voids, no inclusions, no hidden cracks waiting to let go at 4,000 revolutions per minute. This is not just metallurgy, this is ballistic endurance, poured and pressed by men who had seen what happens when steel fails under fire. The rotating mass is overkill. It does not know what failure means. It was supposed to be a grocery getter's heart. It ended up as the engine you want when the grid goes dark and the world gets mean. Air moves with purpose here. 18-inch intake runners, longer than most V8 engines ever dared, draw in the charge, packing it dense and cool before it even sees the valve. That is not commuter compromise, that is tractor logic, built for torque, not show. The air does not trickle in. It rushes, stacks, and hits the chamber with enough inertia to twist the crank at idle. That is why you get torque at 1,200 revolutions per minute and 1,500 revolutions per minute. Numbers that matter when you are pushing a loaded truck uphill in February. Not peaky, not fragile, just steady, low-end force, the kind you feel in your bones. Lose a socket down one of those runners, and you might not see it till next winter. Computational fluid dynamics would confirm it now, but back then it was just common sense. Long runners mean less turbulence, better mixture, every cylinder fed, even when the carburetor ices up. That is why these engines idle smooth after a cold start, even with a cracked plug or a sticky choke. They breathe through iron lungs. Wiring is almost an afterthought. One coil, one distributor, 6 wires. The whole thing will run on a 6-volt battery or a hand crank if you are desperate. No sensors, no computers, no need for anything but fuel and fire. Lose your alternator, hotwire it. I have started one with a jump from a lawn tractor. The distributor does not care. It draws less than 30 amps at idle. It is mechanical immunity. Chrysler built it like a fortress, not by design, but by stubbornness. That is why these engines survive the torture tests. Bench test, dyno room, fluorescent lights humming overhead. You want numbers? Here is what Chrysler did to its own creation. They drained the oil, not a drop left in the sump. They fired it up anyway. Let it idle. Then they brought the revs up. 20 minutes, still running, 30 minutes. The mains start to knock, any modern engine would be seizing, welding itself into a paperweight. The Slant-Six? Bearings scuffed, journals hot enough to fry an egg. But it keeps firing, they pour oil back in, and the pressure snaps right back. Compression? Unchanged. That's not luck. That's mechanical immunity, cast and forged by men who expected abuse. Now forget idle. Let's talk wide open. Factory dyno, 1961. They bolted a fresh 225 to the stand, hooked up the cooling, and dialed in the throttle. 4,000 revolutions per minute, full throttle. Not for 5 minutes, not for an hour, but for 24 hours. One entire day, piston rings scraping, crank hammering, rods flexing. The exhaust manifold is glowing red, paint burning off in sheets. The oil in the pan is black and frothing. Power output drops, barely 2%. Oil analysis shows less than 5 parts per million of metal. That is not a typo. That is not a myth. That is a block and crank that refuse to surrender. I remember machinists standing over the teardown, shaking their heads. One guy, an old-timer with hands like vices, ran his finger down the crank journal. No scoring, no blue, just a faint polish from the bearings. He said you could run this again, and again. That is not marketing, that is a survivor's verdict. This is not garage law, this is factory logbook, bench abuse, dyno chart. Chrysler did not just build an engine, they built a kinetic payload that shrugs off the kind of mechanical violence that would turn a modern aluminum 4-banger into a molten puddle. No oil, no mercy, no surrender. That is what separates the Slant-Six from every other commuter motor. It was never supposed to be a weapon, but it is. You want proof? Forget the lab, forget the dyno. Proof lives on the street, in the scrapyards, in the battered fleet cars that refuse to die. Start with the US Postal Service. Those guys ran Slant-Sixes in mail trucks until the rest of the vehicle dissolved out from under them. Average, over 250,000 miles per engine, sometimes pushing 300,000, and that's with drivers who treat the throttle like a light switch and maintenance like a rumor. I've torn down fleet blocks that spent a decade idling in traffic, oil black as tar, bearings still within spec. The journals, you could shave in the reflection. Scrapyard resurrection is where the myth turns into hard evidence. I watched a kid drag a 225 out of a junkyard in Ohio. The engine sat 12 years, half buried, mice living in the air cleaner. He swapped a fuel line, dumped in 5 quarts of whatever oil he could find, and hooked up a 6-volt battery. 2 cranks. It coughed, spat rust, then settled into a slow, uneven idle. No smoke, no rod knock. He ran it at 1,500 revolutions per minute for 48 hours straight, powering a generator, never missed a beat, never climbed past 190 degrees. That's not nostalgia, that's mechanical immunity, cast in iron, proven by time and neglect. Fleet mechanics have a saying, if it's got a slant, it'll start. One old-timer from the city garage told me they would lose a transmission or two every winter, but the engine never failed. You would have to shoot it to stop it. All the bench tests in the world can't match what happens in the wild. These blocks survive the kind of abuse that makes modern engines curl up and die. Get one running after a decade in the weeds, and you realize this isn't just overkill, it's a fortress. It's the last engine standing when everything else is scrap. Modern SUVs are rolling circuit boards. Lose a sensor, blow a fuse, and you are calling a tow truck if the grid is even up. Now, look at the Slant-Six. The ignition system is so basic, it is almost prehistoric. One coil, a distributor, 6 plug wires. That is it. No computers, no limp mode, no digital hostage crisis. The whole engine will run on less than 30 amps, and I have seen it start on a half-dead 6-volt battery that would not turn over a garden tractor. You can hotwire it with fencing wire if you have to. Distributor cap gets cracked, jam a stick under it, and keep going. This is mechanical independence, pure and simple. When the world goes dark, the Slant-Six shrugs. It does not care about voltage drop, fried modules, or a dead alternator. As long as you have a spark and something flammable, you are in business. You can drain the tank and fill it with whatever passes for gasoline after the world goes sideways. This block does not care. 70 octane? Maybe it is half kerosene, half varnish, the kind of stuff that would make a modern fuel pump seize in protest. The Slant-Six just shrugs. Compression is low, 8.2 to 1, maybe 8.5 to 1, so it will burn what you feed it. I have seen these engines run on gas that smelled like paint thinner. The carb might cough, the idle might stumble, but the crank keeps turning. Try that with anything built after 1990. See how far you get before the injectors clog or the ECU throws a fit. Parts, pull a catalog, pistons, rings, rods, they are still on the shelf. Wizeka for forged slugs, Eagle for rods, Mopar diehards for everything else. You want to rebuild one in a barn after 20 years of neglect? You can. No computer, no special tools, no supply chain drama, just wrenches and some patience. That is why, when every modern car is bricked by a bad sensor or a dead module, the last generator humming in the dark will be running a Slant-Six. Take it from a machinist, you want a lifeline, you build it out of iron. You can call modern cars smart. I call them brittle. This block, it's not smart, it's not pretty, but it's immune to grid failure, bad gas, electromagnetic pulse, hell, even human neglect. All that overkill was an accident, never meant for Armageddon. Yet here we are, 60 years later, and this ancient iron still sneers at obsolescence. That's American industrial might, cast, forged, and utterly unkillable. Drop your thoughts in the comments.